first of 3 lessons involving graphing linear systems. This lesson is called Solving Linear Systems by Graphing. Let's go over our 3 vocabulary terms. First, we have system of linear equations. A system of linear equations consists of 2 or more linear equations in the same variables. It's also referred to as a linear system. Let's take a look at the second vocabulary term. The solution of a system of linear equations. The solution is simply an ordered pair that satisfies each equation in the system. And then term number 3, consistent independent system. This is a linear system that has only one solution. Now let's get started on our examples. Example 1, tell whether the ordered pair is a solution to the linear system. Now we have done problems like this before, going back as far as pre-algebra, where you're given a number or a value for a variable when you first were introduced to it, and you had to tell if it made the equation a true fact. We're doing that here, but this time we're using an x and a y, and we are going to substitute each the x and the y into 2 separate equations. And even though I know we've done this even this year with an x and a y, some of you are still having some trouble, and so I thought it would bear repeating. Some of you are still getting your x and your y confused, so it might be helpful to label them x and y. And we're going to take our first equation here, x plus y equals -2. Our x is -3. Our y is +1. -3 and a +1 do make -2. So here we see that this ordered pair, -3, 1, is a solution to this equation. But in order for it to be a solution to the entire system, it has to satisfy this equation as well. So now let's do this one. X plus 5y equals 2. X is still our -3. Y is +1. So we have a -3 and +5 equals 2. Here we have +2 equals +2. Since this one checks out and this one too, that means that yes, this ordered pair -3, 1 is a solution to this system of equations. Let's take a look at this one. I did the work already. Here we have to solve this linear system by graphing. The first equation in the system is y equals x plus 4, and the second one is 3x plus y equals -2. So what I did was I took this y equals x plus 4, I identified the slope, which is a +1/1. It means we go up 1/1, and still, the reason I put that is some of you are still having trouble understanding that. If that applies to you, make sure you write that in. Our y-intercept here is +4, which means it's 0.04 on the graph. And so I graphed that line, 0, 4, up 1/1. This purple line is that equation. Now excuse me. We have our second equation in the system, 3x plus y equals -2. And you know that in order to graph a line, the equation needs to be in slope-intercept form. So here we are, I put a -3x on both sides. We would have y equals -3x minus 2. That means our slope is -3, meaning we go down 3 and over 1. Our y-intercept is a -2, which means we plot 0, -2, which I did, down 3 over 1, and I drew that line. Now, the solution is here, this point of intersection. This is the solution to this linear system, and this is point 1.5 up to 2.5. And so what does it mean? It means that if you were to plug in this x and that y into each of these two equations, just like we did in example 1, you would have found that this satisfies both equations. It makes both equations true statements. And here we have example 3. It's our last example. I want you to make sure you copy the whole problem. I want you to have all this information. The National Park is a popular field trip. School A rented and filled 8 vans and 8 buses, with a total of 240 people. School B filled 4 vans and 1 bus with 54 people. Every van had the same number of people in it. The buses also had the same number of people. Find the number of people in each van and bus. So we have a lot of work that we have to do here. The first thing we need to do is put together our 2 equations, the 2 equations that make the system in this problem. And then what we'll need to do is graph the 2. And here I've done all the work already. Our first, it tells us that School A has 8 vans and 8 buses with 240 people. So that means our equation is going to be 8x, x is representing the vans, and y is the buses. 8x plus 8y equals our total of 240 people. And you know that in order to graph it, we have to put the equation into slope-intercept form. So I put a negative x on both sides. I know this is a little small, I'm sorry for that. So we have 8y equals negative 8x plus 240. We divide every term in the equation by the coefficient 8, and that gives us y equals negative 1x plus 30. Our slope is a negative 1, our y-intercept is 30. So on this graph, I graphed in the purple 0, 30, and I went down 1 over 1, and it actually anchors. This equation has the same number for the x-intercept and the y. So our second point is here at 30, 0. Next, I took our School B. School B used 4 vans and 1 bus and had a total of 54 people. So we're calling that 4x plus 1y equals 54. I put a negative 4x on both sides so that I could have my equation in slope-intercept form. That gave us 1y equals negative 4x plus 54. Our slope is negative 4 from the y-intercept of 0, 54. From there, I went down 4 over 1. This gets us to be at about 13.5, 0. And the point of intersection is 8, 22. So what I wrote over here is just a short explanation. 8, 22 is a point of intersection. This is the solution to this linear system. So what does it mean for this word problem? It means that each van has 8 people in it, and each bus has 22.